Hello dear friends, welcome to the lecture of geometry. We are studying the plane. In the last lecture we have studied the general form of equation of plane, and we have studied that every equation of every plane is of the first degree in xyz, and conversely every first degree equation in xyz represents a plane, and therefore this is the general form of equation of plane. It's a first degree equation in xyz. So where not all ABC are 0, that condition is written in this form. So another form we have studied, it is L into x plus m into y plus n into z is equal to p. This is known as normal form. So what is the difference between this is a particular form where L, m, n are the direction cosines of the normal, and p is the length of perpendicular of the normal from origin to the plane. So if you want to convert this equation into normal form, that is the transform the equation that we shall see here. Now the two equations we will assume of the same plane. So the derivation of the transformation is the two equations. First we will consider the equation, this one, a into x, the general equation, and suppose that as 1, and the second equation we will have as L into x plus m into y plus n into z, and this term, to get the same form, we will shift on left side, represent the same plane. So if these two represents the same plane, then their coefficients must be in proportion. So this implies, now we may consider the ratio as A upon L or L upon A, that anyway we will consider. So if we find, next we want the values of L, M, N, so therefore this implies we will consider L at numerator and A at denominator. So this implies L upon A is equal to, then M upon B is equal to n upon c, and is equal to, this is p divided by this negative p divided by d, and by using the properties of ratios, this can be written as under root of L square plus m square plus n square divided by, or that will be plus or minus. So this is, because there is a radical sign, we have to write plus minus sign, root of a square plus b square plus c square, and that is equal to, now this we know that LMN are the DCS, direction cosines of the normal to the plane, and therefore L square plus m square plus n square is equal to 1. So this is root 1, and root 1 is again we have to consider as 1. So therefore this will be plus or minus 1 divided by this one, or that we can write plus or minus 1 upon this, we shall write in short form as summation a square, and now we will suppose this as the third relation. Now we know that this p is always positive. So since, because p is the length of perpendicular, p is positive, so we have the relation as p divided by negative d. P divided by negative d. So negative sign will attach with this d, and the right side is summation 1 upon root of 1. So this is 1 divided by root of sigma a square, and that is plus or minus. It is plus or minus, or that sign is actually for the radical. 1 divided by plus or minus root of summation a square. Summation a square we have considered this in short notation. Summation a square means a square plus b square plus c square. Now we write this from this we will have, if d is positive, then the left side is negative because of this sign. So therefore we have to take the negative sign of the radical. So if d is positive, we take negative sign of radical. And if D is and if D is negative, if D is negative, see the sign. If this D is negative, then negative of negative becomes positive. So this side is positive means we have to take the same sign, that is positive sign of the radical. We take the positive sign of the radical. And now we will consider these sign convention, sign notation. So thus there will be two cases depending on D is positive and D is negative. Thus if D is negative, or first we shall consider the positive case. Thus if D is positive, then what will be the values of say L, M, N we will obtain from 3. Then from 3, what is L? Now you see first fraction and the last, first ratio and the last ratio. So L will be, shift this A at on the right side, that will be at the numerator. So L is, and positive, negative, so which is the sign to be taken? D is positive, we take negative sign of the radical. So negative sign is to be taken. So L is equal to negative A divided by summation A square, root of summation A square. And what is the M? M will be negative B divided by, equate this M, this B is to be shifted on the right side, and that is B divided by summation of A square, and that N is negative C divided by under root summation A square. And further what about last is P? P will be, P is equal to, now you see the right side is also negative, we have to take the negative sign of this, and this negative sign cancels and we get positive D divided by under root of summation A square. So thus this is the case, these are the values of LMN and P in the normal form when D is positive. And if D is negative, so we will have to write the other set of values. If D is negative, then from 3 again. See, if D is negative, we take the positive sign of the radical, and therefore what will be the values? L will be positive. So these signs will be changed, and thus we get L is equal to A divided by under root of summation A square, and M will be B divided by summation under root A square, root of summation of A square, and N is C divided by under root summation of A square. And what about N? See, these are the values. And what about P? P will be, now P will be negative, that is negative D divided by under root summation A square. So these are the values we have. And now thus from the equation second, we have to put these values of LMN and P in second equation, and then we will get the equation of this plane in normal form. So therefore from 2, the normal form is therefore from 2, the normal form of plane is now you see, first case is D is positive, then these are the values, and thus it is negative A divided by under root summation A square is negative A divided by under root summation A square into X. We are putting the value of L here into X. What is B? M is negative b divided by under root summation a square and into y plus it is again negative, so c is negative, and that is c divided by under root summation of a square into z, and this p is actually to be written on right side. In normal form we write this p on right side, but for comparison we have written it on the left side to compare with the d. We have written as, but we will write on it on the right side, and that is p, and what is the value of p is d divided by under root summation a square. This is the case if d is positive, and if what happens the other form, if d is negative then these values are positive, and a divided by, so it is a divided by under root of summation a square into x plus b divided by under root summation a square into y plus etc. And now you see p is negative, so p we are writing on the right side, so we have to observe second form, and in the second form we have to put these values. So here we have used the property of ratio, so it is negative d divided by under root summation a square. If d is negative, that is the case, if d is negative, and thus we have transformed the equation 1 which is in general form to a normal form in this form, and this is the equation of plane in normal form. Now we before considering one example we will write a remark. So here in the equation of plane in general form the coefficients are a, b, c, and what a, b, c represents that we shall write. In equation of plane, in the general form of equation of plane, that is a into x plus b into y plus c into z plus d is equal to 0. These are proportional to the direction cosines of the normal, and that means ABC, the quantities which are proportional to the direction cosines are called direction ratios, and therefore ABC are the direction ratios. ABC are the direction ratios of the normal to the plane. Normal means perpendicular to the plane. ABC are the direction ratios, or in short we may write this as DRS of the normal to the plane. So this plane, and thus every time we write the equation of plane in general form, always the coefficient of x, y, z represents the direction ratios of the normal to the plane. And now we consider one example of transform the equation in normal form. Example: transform the equation any example can be considered as, say, 2x minus y plus 2z plus, or I may consider as minus 3 is equal to 0. Transform the equation to the normal form. Transform the equation of the plane. This is the equation of the plane to the normal form. Now we will have to use the derivation that we have obtained. This is the normal form. The normal form is either this or this one. And what is when this form is to be used? D is positive. Then we have to write negative signs of this. So here what is d? Here d is this ax plus b into y plus c into z plus d is equal to 0, and d is the constant in the equation, last constant, and therefore it is negative 3, and that is d is negative. Solution for this: here a, b, c are: a is 2, b is negative 1, c is 2, and d is minus. That is d is negative. Since d is negative, the normal form is we have to consider d is negative. See, this d is negative, then this is the form, and if d is positive, then this is the form. Only the change in sign is there, and therefore here d is negative, the normal form is. So we will write directly 2 divided by 2, it is positive. 2 divided by what is summation a square. Summation a square here is under root of a square means a square plus b square plus c square. That is 2 square plus negative 1 square plus 2 square, or that is 4 plus 4 plus 1, that is 5, root 5. And thus this is 2 divided by root 5 into x. And so only we have to divide the coefficients of x, y, z by under root of summation a square and note the sign. So same thing is there here, and here the sign is negative if d is positive. The sign is positive, d is negative. Here d is negative, and therefore it is 2 divided by root 5 into x minus what is y, it is 1 upon root 5 into y, and plus 2 divided by root 5 into z is equal to, and what is the right side? It is d. D is negative. D, that is minus 3. So here we have to consider this. So minus of d, minus of minus d. The case is here. Minus d is minus 3 divided by root 5. So this is the equation of the plane in normal form, and thus we have obtained it. So the values of these are the values of L, M, N, and this is the value of P, 3 divided by root 5. So in this way we can transform equation in normal form. Now one more thing we shall consider is angle between the planes. Now that is a simple result. Now how to decide angle between the planes, that we have to see. Angle between the planes. Now suppose the two planes are like this, say folded in this way. The two planes are folded like this. Then the angle between the two planes will be this angle. So if you consider the figure, then suppose one plane is like this, and another plane we may have in this way. See, this is the line of interaction of the planes, and now the angle between these two, or these are the two pages of a book folded like this, and that is the angle between the two planes is this one. This is the angle between the two planes. Now it is same as the angle between their normals, because as the plane rotates, the perpendicular to the plane also rotates. Or if this is one plane and if the plane, another plane is perpendicular to this, so the normal to this plane will be outward, or this is the normal line perpendicular to this board, and then if we consider the another plane like this which is perpendicular to the plane, its normal will be in this way, and thus the two normals will be perpendicular if the plane is perpendicular, and otherwise the angle between the normals is the angle between the planes. So the angle between the normals. So I have to correct this spelling of angle. The angle between the normals, angle between the planes is the angle between their normals. Now we consider the two planes in general form. Consider two planes as say first in general form we are considering a into x plus b into y plus c into z plus d is equal to 0, and another we will consider suffix notation a1 into x plus b1 into y plus c1 into z plus d1 is equal to 0. Now to find the angle between these two planes means we have to find the angle between their normals. Now to find the angle between normal is a line, and to find the angle between two lines we have to consider the DRS of the two lines, and we just have seen the DRS of normal to the first plane is ABC, and the DRS of the normal to the second plane is A1 B1 C1. So we have to note down only the DRS of the two normals. So the DRS of their normals or direction ratios of their normals are, for the first plane these are A, B, C, and for the second plane these are A1, B1, C1 respectively. And now if suppose theta is the angle between the plane and that is the angle between the normals, so therefore if theta is, and again there will be two types of angles, acute smaller angle and a bigger angle that is greater than 90, less than 90 and greater than 90. So if you want the acute angle and if theta is the acute angle between the planes, then we will have cos theta. Cos theta is, we will have to write only the absolute value. So angle between the normals, and we know the result of angle between the two lines with DRS as ABC and A1 B1 C1 is A into A1. Cos theta is equal to A into A1 plus B into B1 plus C into C1 divided by under root of summation of A square plus B square plus C square, and secondly it is under root of A1 square plus B1 square plus C1 square, or that can also be written in brief as summation root of sigma A square and root of summation A1 square. So this gives the angle between the two planes. We will have one example. Find angle between the planes, or find acute angle between the planes. And I shall write the equation of plane as say 2x plus y and minus 3z plus 5 is equal to 0, and minus, or we will consider positive sign first, 3x plus 2y and plus say z plus 7 is equal to 0. Find any equation we can consider of this type in first degree equation, because every first degree equation represents a plane. Whatever coefficient at our wish we can consider. So solution for this: if theta is the acute angle, between the planes. Then we will have the relation, or we will use this directly. Then what is cos theta? Cos theta will be absolute value of a into a1. And we will have the values of DRS. DRS 2, 1 and minus 3. Here the DRS are 3, 2 and 1. And we have to take the product and add it. So 2 into 3. So we are writing directly 2 into 3 plus, and this is 1 into 2. B into B1. See, these are the direction ratios of the normal. So that is 1 into 2 and plus, next will be minus 3 into 1. So divided by under root of sum of squares of the coefficients here. 2 square plus 1 square, etc. And under root of here 3 square plus 2 square and plus 1 square, or that will be absolute value of, this is 6 plus 2, 8, 8 minus 3 is 5, divided by square root of, and this value is 4 plus 1, 5, 5 plus 9, that is 14, and this value is 9 plus 4, that is 13 plus 1, again it is 14. Let me check it. And that is 5 divided by 14. This is equal to 5 by 14. This is the value of cos theta, and therefore theta is inverse, cos inverse of this 5 divided by 14. So in this way we can find the angle between the two planes, which is same as the angle between their normals. So thus we have studied how to transform a general equation to normal form and how to obtain the angle between the planes. So remaining part we will continue in our next lecture. Thank you.